Hi, my name's Adam Bush, and I'm from Team 6210 Viperbot Strike here in Austin, Texas, and I have something very exciting to show you guys today. Once first announced that they were no longer using the NXT-based system, but switched to a Java platform, we thought that some teams that don't have any Java experience might be at a slight disadvantage for this year's challenge because the autonomous is a very important aspect of this game. So we decided to create an autonomous generator, and the aim of this program was to allow for anyone to read, write, and understand what an autonomous program does, and sort of allow for anyone to make these. So if we open up this program, we can see that we're welcomed with a very nice text window, some nice buttons, and probably one of the most helpful buttons is this help button right here. And what it does is it gives you this long list of commands and example code that you can use in this program. So I'm going to be highlighting this first section, the command section, and then I'll later be talking about groups, which are really helpful if you have a large list of motors, say your drivetrain, where you might have 4 motors, and it just makes writing these programs a whole lot easier. So we're going to start with these most basic command, the wait command. What this does is, as you might think, is it just stops the code for however long you tell it to. So we can do this by just simply typing wait and then duration. So if we just say wait and then a number, it's going to wait the specified amount of time in milliseconds. And although that might be helpful if you want really precise timing, if you just want it to read a whole lot easier, you can just easily add seconds. Oh my gosh, I can't type. Seconds to the end of that. What this will do is it will wait 10 seconds in order for that first sort of bell to ring where your robot is allowed to cross over to the other team's line zone without getting a major penalty. And this can be very helpful if your robot is prone to sort of getting knocked off course by debris. So we're just going to write a very simple autonomous program with this. So say we had 2 drive motors. We can just copy over this command. And the way you use it is you can set the motor's speed. So say we had a drive motor called drive left. That was our left drive motor. And we can set its speed from 0 to 100. So since our robot is very fast, maybe we just only want it to run at 50% speed for autonomous. So since your robot hopefully has 2 motors to drive, we can set the motor drive, not drive, what am I typing? Drive right. We can also set that speed to 50. So if you've ever worked with a robot before, you might see a slight issue with this, and that's if you set 2 motors the same speed and the same direction that are on opposite sides of a robot, then you're just going to spin in circles because the 2 motors are going opposite directions when flipped around. So in order to fix this, we need to set one of these motors to run backwards, and we can easily do that by typing set motor. Let's choose the left motor. Drive left, L-E-F-T, direction, reverse. And you can see that command right there. So this is great. So what this program does is we just wait for 10 seconds and then drive forward for an infinite amount of time. So in order to fix this, we need to wait, say, another 5 seconds if we want our robot to drive forward for 5 seconds, because you might find that that's how long it takes for your robot to drive to the other side of the arena. So if we want to stop our motors, we can do set motor drive left speed just to 0. And we could just type that again, but I'm feeling a little lazy, and I might just do copy and paste that. So now we're just going to drive forward for 5 seconds. So Now our robot is aligned with the climber dropper because that's how we started it supposedly. So we might have a servo with the name climber holder, and this could be the little clothes hanger thing or little bucket that you have your climber stored in before the game starts, and those are what you drop into the little bucket. So we can set the servo climber holder position to 180 degrees. So what this will do is it sort of like sets the position of the servo to like from anywhere from 0 to 180 degrees, as highlighted in this command. So now that we dumped our climbers and our motors are stopped, then we're basically set. So you can't really just use this in your send that code to your robot because it doesn't really understand English, hence why we sort of made this program. So what you want to do is click this compile button, and it will spit out this long list of Java code that the robot knows how to use. So if we open up our Android Studio, which you can find many tutorials on how to set this up for your robot online. I can link a first one in the description. And what you can do is it's really simple to move this text to this program. So we can do that by making a new file, a new Java class, and we can call this autonomous op mode, and then hit OK. And notice I called this autonomous op mode because that's the same name as this. And you'll see when you'll save your file in the autonomous generator program, then this name will change. So this couldn't be simpler. You could just copy all of this and paste it into here. Oh, I might have copied a little too much. So what this does is, and this is basically your op mode. And notice I left this first line on there, the package, and that can change for you guys. Depends where you made your file, but just sort of leave that there. It might give you an error. Just ask a question in the comments if that happened. So now that we have this pasted, we can go into our FTC op mode register, which should be in your FTC robot controller folder. And it defaults with a bunch of other op modes registered. And here's where you can put your autonomous op mode. And whatever you put in here is what's going to show up on your driver phone. And then in here, you just put autonomous op mode .class. And notice this is the same name as this file. And you might get an error saying that you need to import it. And you can resolve that by pressing Control Enter, I think, and it will import it for you automatically. So once you have that all finished, you can just press the Run button, and it should upload to your phone if you have it plugged into your computer. So that's about it for this generator. I'm going to make a second video highlighting groups and how those work, and I can post some example programs online with this generator as well. So like always, if you have any questions, please put them in the comments and we'll be very happy to answer. Thank you for watching.